Hey everyone, it's Mr. Roy. In today's lesson we're going to be learning a powerful use of quadratics. We're going to be learning to solve quadratics. Now, something you're pretty used to is solving linear equations. This is something you've been doing since ninth grade, where we have an equation and you need to figure out what x or y or a or b or whatever equals. We're going to, though, now take this into a new realm where we're solving things that have a squared term in them. And we're going to need to apply all the skills we've learned so far with quadratics to make this happen. So here we go. Let's start with something that we're a little more familiar with. Let's start with solving linear equations. So here's a couple of linear equations, and let's see if we can solve for x in these equations. So for my first one, I say, okay, 2x plus 10 equals 0. I'm going to subtract 10 from both sides. So I'm left with 2x equals negative 10. And then I can divide both sides by 2. 2 divided by 2 is 1, so we end up with x equals negative 10 over 2, that's negative 5. So x is negative 5. And I could sub that back into my equation if I wanted to check it. My next one over here, oh, this is a good old two-step equation, very similar to the one we just did. Let's subtract 5 from both sides. So we end up with 3x equals negative 5. Let's divide both sides by 3. And we end up with x equals negative 5 over 3. Okay, so that's solving linear equations, and that's something we've done a lot of. This something we're pretty comfortable with. Now, sometimes we could get into a situation where we're solving a linear equation where they might be in factored form, kind of like this here. Now, we're kind of familiar with this. This is our good old factored form where we've got things multiplying one another. This first one, C, looks like we've actually had a common factor that's been a 2 that's been factored out of there. So there's a couple ways we could solve this. The first way you might think about solving this is saying, I'm going to multiply through the brackets and see what we get. So we've got 2x minus 8 equals 0. And then you say, okay, I'm going to add 8 to both sides. So we end up with 2x equals 8, and I divide both sides by 2. And so I end up with x is 4. So that's one way to do that, but here's another way that you might think about doing that. I notice on the right-hand side here, this equals 0. Now I've got 2 times the stuff in the bracket equals 0. 2 times the stuff in the bracket equals 0. Well, I know if I'm getting an answer of 0, one of those things must equal 0, right? One of those things must equal 0, because when we're multiplying and we end up with an answer of 0, one of the two things we're multiplying must be 0. Well, that 2 definitely is not 0. So what does that leave us with? The stuff in the brackets must be the thing that equals 0 to get us to that answer of 0. 2 times something equals 0, it must be the something. So here's a different approach we could take. We could say, well, it's got to be the x minus 4. That's got to be the thing that equals 0, because 2 definitely isn't. So that means x is going to be 4 when I add 4 to both sides. You notice we get the same answer, but we didn't have to mess around with multiplying through. We just looked at the brackets and said, that's got to be 0, because 2 isn't 0. We get a similar situation over here for D. We say, okay, we multiply them out and we get an answer of 0. That means one of these brackets, or both, but in this case it can't be both, but one of these brackets has to be 0. Either x plus 1 has to equal 0 to get us to that answer of 0, or x minus 3 has to equal 0 to get us to an answer of 0. It's got to be one or the other. So here we go. It's either got to be this one, in which case x plus 1 equals 0. So let's subtract 1 for both sides. X has got to be negative 1. Or we could have, let's put it up here in the same spot actually. Or we could have x minus 3 equals 0. So that would mean x is equal to 3. Now you're used to doing this because when we are working with quadratics, which this one actually is, we look at this and we say, oh, okay, to get to zeros, we just take what's in the brackets and we give it the opposite sign. So x plus 1 means one of our zeros is x equals negative 1, and x minus 3 means one of our zeros is x equals positive 3. When we're solving these equations, though, when we're using quadratic equations to solve a problem, we could have in this situation either x is negative 1 or x is positive 3. Either of those are possible answers. Okay, so let's look at our big idea here. When we're solving a quadratic, if we want to solve a quadratic equation and we want to figure out what x equals in our quadratic equation, what are the possibilities that we could have? The equation needs to be equal to 0. So this is a really important point. You'll notice in the previous examples we always had the equation equal to 0. That's going to allow us to identify the zeros, which are the solutions to the equation. So the reason they're called the zeros, which you didn't know up until now, is because they need to be equal to 0 when we're solving our equation. So we're always going to make sure that our equation needs to be equal to 0. That's something we're going to get really used to doing. Our equation is going to need to be equal to 0 so that we can get to an answer. There's also another name for solutions. I've mentioned this before, but solutions are sometimes called roots. So we can call them zeros or solutions or roots. That all means the same thing. And depending on who you're talking to or what, say, book you're looking at, you may see those different words used interchangeably. Now, for all the stuff we're doing today, you could go to Desmos, just plug this thing in, and then look at the x-intercepts, which are the zeros, the solutions, the roots, right? It all means the same thing. You could plug it into Desmos and just look for them. But we're going to actually bring our skills to bear that we've been working on in this unit to help us answer these solutions. So we actually know what we're doing when we use Desmos for something like that. Okay, so when I look at my first example here, it says solve. I'm trying to find out what x could be, right? Just like when I solved a linear equation, I figured out what x was. In a quadratic equation, we may have more possibilities. We may have more than one answer. And in this case, we will. Now this one's pretty easy to do, right? Because we're pretty used to this. We say, oh, just look in the brackets. So x is going to be negative 4, or x is going to be positive 6. We did the opposite signs, right? And of course, we say those are the zeros. So we're pretty used to doing that just by looking at the equation once it's already in factored form and figuring out what the zeros are. Of course, we might be in a situation where it's a little less obvious. Let's put an arrow in there. We might be in a situation where it's a little less obvious. In the second one, for example, you can look at this and say, okay, I know that I'm going to say x plus 5 equals 0, so that means x has got to be negative 5. Right? Normally we just do that automatically and say x is equal to negative 5 because it's quick and easy. With this one, it's a little more complicated, right? We've got 2x minus 3 equals 0 because one of those has to equal 0. Let's solve for that. So that's going to be 2x equals positive 3 and x equals 3 over 2 or 1.5. Okay, so finding those solutions, those zeros, was not that hard when it's in a nice factored form like this. But of course, it may not be in a nice factored form. So let's have a look when that's not the case. Here's a situation where we've got some things that are not in factored form. So this is actually why we practiced our factoring. It was to get us to this point. So let's have a look at our first one. We're going to factor this. This is a simple trinomial. So we're going to need to factor first. And I'm going to put a little note here. I'm going to say, factor first. We say, okay, it's a simple trinomial, so I know I'm going to split it up into brackets like this. We're going to have an x here and an x here. We need two numbers that are going to multiply to 12 and add to 8. So we say, what are those two numbers? Well, those two numbers are going to be 6 and 2. Those add to 8, multiply to 12. Okay, so we've factored it, and now we can say, okay, what are the solutions? X is going to be negative 6, or x is going to be negative 2. Just by looking in the brackets, we can tell that nice and easily. What if we got a situation like this one over here? 4x squared minus 9 equals 0. Well, I recognize that's a difference of squares. That's a difference of squares. Those ones are pretty quick and easy. I'm pretty used to those. Let's take the square root of our first one. The square root of 4x squared is 2x. So I'll put my 2x here and here. I know I've got a minus and a plus. And then I'm going to take the square root of 9. It's going to be 3 and 3. So what are our solutions? Well, we're going to have 2x minus 3 equals 0. That's one of them. So 2x equals 3 and x equals 3 over 2. Our other possibility, this one we can kind of just jump the line because only the sign's going to be different. So we know we're going to have x equals negative 3 over 2 when we solve that one. Okay, so we've solved that equation. Cool, so far so good. Let's have a look at this one here. Actually, we got two examples here that have a similar issue with them. Take a moment and think about it. What is our problem with trying to jump in and solve this equation? Well, our problem is this isn't following one of the key tenets we had here. We said the equation must be equal to 0 first before we can solve for it. Neither of these is equal to 0. So we're going to need to change these around a little bit before we can solve for them. So I'm actually going to put this note down here to just remind us when we're doing this. We need to make these equal to 0. So we're going to need to move everything over to one side of the equation in order to make this equal to 0. So for my first equation, let's move everything over to the left. If I moved it all over to the right, I would still get the same answers in the end. But let's just move everything over to the left because we got to pick one. We're going to subtract 18x from both sides, and we're going to add 40 to both sides in order to move those over. So that means on the left side, we got 2x squared minus 18x plus 40. And on this side, we got 0 because we did the operation to get rid of those. Right? I suppose I should also put a minus 18x over here and a plus 40 over here because we're doing it to both sides. Okay, so now we're in a form where we can do something. Now I say, okay, let's factor this to try and figure out the zeros. Okay, I can factor it. First, I notice I can take a common factor out of here. So let's common factor first. Let's common factor out of 2. I got my x squared minus 9x plus 20 equal to 0. Let's factor this. This is a simple trinomial, so let's do that. I need to find two numbers that are going to multiply to 20 and add to negative 9. I know they're multiplying to a positive, adding to a negative, so that means I got two negative numbers, because that's the only way that's possible. What are my numbers? They're 4 and 5, negative 4 and negative 5. So what are my solutions? My solutions are x equals 4 and x equals 5. Those are my two possible solutions to that equation. Okay, how do I solve for x in f? How do I solve for x? How do I solve for x? Well, I got to move everything over to one side. Let's do that. Let's add 12 to both sides. So we end up with 2x squared minus 11x plus 12 equals 0. Now, I'm going to factor this. I need to find my two numbers. Turns out this is a complex trinomial because I cannot factor a 2 out of there. So I need two numbers that are going to multiply to 2 times positive 12. So that's, they're going to multiply to 24 and they're going to add to negative 11. So two numbers that'll do that. That's two negative numbers. Turns out that's going to be 8 and 3 are the two numbers I need. 8 and 3. So I'll split my middle term into two pieces, like we've had lots of practice doing. And we'll rewrite this with my middle term split up. We're going to have minus 8x minus 3x plus 12. So I split up that middle term into two pieces. Now let's do our common factoring. I can common factor a 2x out of my first one. That leaves me with x minus 4. I can common factor a negative 3 out of my second one. That leaves me with x minus 4. And then your annoying math teacher goes, aha, look at this and look at this. Those are the same, so I can common factor an x minus 4 out of my first term. I'm left with a 2x. I can common factor an x minus 4 out of my second term. I'm left with a minus 3. And then we say, okay, cool. So what are our zeros there? Well, the first one's pretty easy to see. It's just x equals 4, right? Because if I set the first one equal to 0, I know I'm going to get x equals 4. What if I set my other one equal to 0? I got 2x minus 3 equals 0. One of them's got to be 0 to get my whole thing equal to 0. So add 3 to both sides, divide by 2, I'm going to end up with 3 halves, 3 over 2. Okay, so those are my two possible solutions for x. right? This is a bit of a different way of thinking than with linear equations. With linear equations, we're used to x always equaling something, one thing. When we're solving a linear equation, we always end up with an answer and we say, oh, x equals that. I got it. I figured it out. I figured out what x equals. In quadratics, it's more complicated. Because it curves and goes back the same way it came from, you can actually have two different possible answers. Think about it like this. If I'm standing in a field and I throw a ball up in the air and I say, okay, well, let's say I throw it really high. And I say, okay, um, at what point is the ball at 10 meters in the air? Well, there's actually going to be 2 points, right? Let's get a green pen here and draw a little picture of what that would look like that. There's going to be 2 points. There's going to be a point here where it's at 10 meters on its way up, and there's going to be another point here at 10 meters when it's on its way down. So there's actually 2 answers. And that's why with quadratics, when we're solving for x with an equation that happens to be a quadratic, we'll often get 2 answers. We're not always going to get 2 answers. I'll show you some situations later where you might only have 0 answers or 1 answer, but most of the time we're going to have 2. So that's an example of why you would have it, a ball going up and coming back down. It hits that 10-meter mark. If I draw a straight line right there, at 10 meters high, it would hit it in 2 different places. Okay, so quadratics are very different in that there's not just one thing x could be 2 different things. Okay, now let's use this new word root, right? Root to mean a solution. So is x equals 2 a root of the equation 3x squared minus 2x minus 8 equals 0? Basically, I'm saying, what do I need to sub in for x to make that whole thing on the left equal to 0, which is what it is on the right? So is that a solution? Okay, so we're saying roots are values that make equations, quadratic equations equal to 0. So roots are values that make quadratic equations equal to 0. So is x equal to one of the roots, one of the solutions? Let's find out. We're going to take our equation and we're going to sub in and we're going to see. Okay, so we'll say 3 times 2 squared minus 2 times 2 minus 8. What is that going to work out to? Does that equal 0? We'll find out. Okay, so 2 squared is 4, so 3 times 4. 2 times 2 is 4. 3 times 4 is 12, so 12 minus 4 minus 8. Does that equal 0? Yes, it does. So we find that 0 equals 0. And so we say check mark. We say therefore it is a root. Okay, let's take this to a scenario that we might run into. Here's one with a rocket launching into the air. So this is similar to that baseball example I just talked about. The rocket is launched upwards in a parabolic arc. Right? Anything that's moving in a gravitational field is going to move in a parabolic arc. The height of the rocket can be modeled by the equation height equals negative 10 times t squared plus 200 times t, where h is the height in meters and t is the time elapsed in seconds. So we got 3 things that we're looking for. When does the rocket reach its maximum height? What is the maximum height of the rocket? How long is the rocket in the air for? And when will the rocket reach a height of 640 meters? Finally, we got the trickiest part, and that is, how long is it above this height? So really, these are some tricky questions, and C and D we've not been able to do before. We've not known how to answer a question like that. Really, D is a pretty challenging one. You're saying the rocket's flying through the air. At what point is it going to reach 640 meters up? And then it's going to come back down and reach 640 meters again. How long is it in that height above 640 meters? How long is that stretch? That's actually like a pretty powerful question to be able to answer when we're dealing with things like that. So this is rocket science. You know, when people say things aren't rocket science, well, you're actually doing rocket science right now. This is rocket science. So we say, what are we looking for? Right, what are we looking for? Vertex, axis of symmetry, the zeros. What are we actually looking for here? Let's try and match a couple of things up. So first one, when does the rocket reach its maximum height? That's our t value for time, right? Because it's saying when. We want to know the time. Well, time is our x coordinate in this thing, right? H is our y, time, t is our x. So the axis of symmetry is what's going to give us that answer, when. Now, what is the maximum height, right? Height is our y value. We want our y coordinate of our vertex to figure that out. So we need our x coordinate of our vertex, that's our axis of symmetry. We need our y coordinate of our vertex to figure out the second one. And then how long is it in the air for? We need to know our zeros. If we know our zeros, we can figure out what the time is in between those two different zeros. So let's jump in and try this. If you feel comfortable with the first two, maybe even the first three, go for it. Try them on your own first and then watch me do it. Okay, that'll be really good practice to try those out. Okay, let's jump in. Here's A. When does it reach its maximum height? So that's going to be the time. That will be our x coordinate of our vertex, or in this case, our t coordinate. So I'm going to say, okay, t is going to be equal to negative b over 2a, right? Negative b over 2a, that's our formula. So what's our b value here? Well, a is going to be our negative 10, b is going to be 200, c is 0. There is no c value there. So negative b is going to be negative 200 over 2 times negative 10. We work that out, we're going to have an answer of 10. So therefore, we have a maximum at 10 seconds. So we'll say therefore, max is at 10 seconds. Okay, what about B? Well, how do we get our y coordinate, which is our height, when we know our x coordinate of our vertex, our axis of symmetry? Well, we just sub it into the equation. So we'll go, okay, height is equal to negative 10 times t squared. The time is 10 seconds in this case. So we're just going to be subbing into our equation. We work that out and we find that that's going to be equal to 1,000 meters. So therefore, we're going to say max height is 1,000 meters, also known as a kilometer. Okay, so those we were doing last unit, we're probably like pretty comfortable with that. Let's change colors here and go to C. How long is the rocket in the air for? This is a little tricky, right? So here's our axis here, and the rocket starts here at time equals 0, and it's going up, 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 and then it comes back down. So that's our height and that's our time. So we actually have two zeros, one where it's launching and one where it's landing again. And we say, okay, it's not in the air when height is equal to 0. So what we want to do is we want to find the times when height equals 0. We know what happens at right at the beginning here. When time equals 0, it hasn't launched yet. But how much time has elapsed when it lands back on the ground? Well, let's take our equation, but let's sub in a 0 where height used to be. This will help us to find the time for those two spots where the height is 0. We could actually sub anything we wanted in for the height, and we would find those spots. We could have subbed in a height of, say, I don't know, let's say halfway up, 500 meters, right? Right here and right here, because we know it goes to 1,000. So 500 meters would be halfway up. How much time has passed when it reaches 500 meters going up and comes down and gets to 500 meters again on the way down? I don't know what times those are at, but we could have subbed in 500 right here. But we didn't. We actually want to know this, when it hits the ground, right? And when it launches, we know it's at 0, but when does it hit the ground again? So let's set it equal to 0. Good. That's how we actually like to solve these. We're going to need to factor this, though. So how do I factor this? Well, I always look for common factors first. I notice I can pull a negative 10 out of each of them, and I can pull a t out of each of them, because they at least have a t. So that would leave me with just t for my first one, and that would leave me with minus 20 for my second one. So I just had to do common factoring. That's all. Okay, that's pretty nice and convenient. Now, I noticed this first one here, this first t is like, it's kind of like this in a bracket, right? It's basically t plus 0, but we don't actually write the t plus 0 part. We just write it as t on its own. So we say, okay, well, what are my solutions here? Well, here's my first one. This is at the start. We say at the start, t equals 0. Okay, that's one of the ways we could get an answer of 0 is if that one equals 0. What's the other way? This is at the end. We say, okay, t is going to be equal to 20 because t minus 20 equals 0. Solve for t, we're going to get t equal to 20. So 20 seconds is our answer, 20 seconds. So we can say from 0 to 20 seconds, it goes up and back down. So we can say, therefore, the rocket is in the air for 20 seconds. Rocket's in the air for 20 seconds. Okay, so far so good. That's great. We set up our equation, we said height equals 0, we factored, and then we found our zeros based on that factored form. What about this last one? When will the rocket reach a height of 640 meters? And how long is it above this height? Okay, whew. So we need to find when it reaches 640 meters, let's say it's right there, what is that time, right? I don't know when it reaches that. And it's going to come back down and reach 640 meters again right there. What is that time? I'm not sure. And what's the difference between them that will tell me how long it's above that? So this arc here, how long is it above 640 meters? Well, I'm going to have to figure that out. Here we go. Let's do it. We're going to take our equation and we're going to say, okay, this is d. I'm going to take my height and make my height 640 meters. So in my equation for height, I'm going to substitute in 640. And then of course I got my regular equation, negative 10t squared plus 200t. Now you might think, oh, I just factor the stuff on the right, but remember that rule. I need to make the equation equal to 0 in order to solve for t. Now in purple, in the previous one, I was setting my height equal to 0, so it was good to go. But this one, it's not equal to 0, it's equal to 640. That's no good. So what do I do? Well, I'm going to subtract 640 from both sides so that I can have it equal to 0. That'll get rid of everything on the left, and I'll just end up with a 0 there. What have I got on the right, though? Minus 10t squared plus 200t minus 640. Now my equation is equal to 0 and I can solve. I'm going to need to put it in factored form though. Can I factor this thing on the right? So this is a tricky step. We sub in a value, we move everything over to one side, now we're ready to solve and we can get powerful answers because of it. First, let's common factor. I can common factor out a negative 10. Let's do that. That leaves me with t squared minus 20t plus 64. Okay, this is a simple trinomial. That means it's going to end up factoring like this. An x here and an x here. They multiply to a positive number, add to a negative number, so I know both my numbers have got to be negative. What are those two numbers? Multiply to 64, add to negative 20. Well, the answer is negative 4 and negative 16. Those are my two numbers. Well, let's solve. Now that we've got it in factored form and it all equals 0, let's solve. X minus 4 equals 0. That means x equals 4. X minus 16 equals 0. That's the other possibility. That's the other way to make this whole thing equal to 0. One or the other of those things in the brackets have to equal 0. So that's going to be x equals 16. So what does this actually mean? Let's go back to that picture. That means the rocket gets up to 640 meters at 4 seconds. And it does it again at it comes back down at 16 seconds. So what's the difference between those two? Well, the difference between those two is going to be 12 seconds. So we'll say, okay, therefore, the rocket first reaches 640 meters after 4 seconds. It's above this height for 12 seconds, from 4 to 16. Okay, so you are doing rocket science when you do this. This is actually the kind of math that was done in order to put people in space, put people on the moon. This is literally rocket science, but quadratic equations relate to all kinds of things in math. And once you start getting into representing things with math, quadratic equations are popping out all over the place. Okay, so now you've got the basic skill set you need to solve quadratic equations. You used to be able to solve linear equations in grade 9. Now, in this grade 10 math course, you can solve quadratic equations that are often going to give you two different possible answers to this question, and then you're going to have to interpret them. Time for some practice. Let's go for it.